All right, so once again, this is a continuation of 1.5. This is just part 2. Today we're going to be going over simplifying radicals that have the negative underneath them, as well as division with your imaginary numbers. So with your radicals that have the negative, if you have a negative underneath an odd index radical, so like the cube root, the fifth root, the seventh root, and so on, that negative is okay. You can just pull the negative out and it's part of your answer. However, we said before that you cannot have a negative underneath an even root or an even index or radical. So with all of these, you're going to be looking at the square root. So your index is 2. That's an even number. If there is a negative underneath that radical, we said yesterday that the square root of -1 is equal to I. So you would pull that -1 out first and represent it with I. So if you look at example 1, you have the square root of -25 plus the square root of -36. The negatives underneath, again, pull them out, represent them with I. You then would have I times the square root of 25 plus I times the square root of 36. Well, the square root of 25 we know is 5, so that would give us 5I. The square root of 36 we know is 6, so that would be 6I. From here, we can just combine like terms since they both have an I attached to them, and that would give us 11I. For example 2, we have the square root of -27 minus 3 times the square root of -48 plus the square root of 12. That -3 square root -48, a lot of you had problems with this on either it was your first test or your first quiz. Whenever you have a number in front of the radical, if that radical can simplify, you have to multiply whatever you take out of that radical by the number that's in front. So just a little bit of a review, that -3 is going to multiply by whatever that square root of that -48 simplifies to. Okay, so starting with the negatives underneath the radicals, you have the negative with the 27, so that's going to become a positive if you take the negative out, and that's going to become I times the square root of 27. Then you have the negative underneath the radical with the 48, so that'll come out, go after the 3, so that would be minus 3I square root 48. Then that square root of 12 does not have a negative underneath it, so it's just going to stay the square root of 12. From here, we're going to simplify each of those radicals. For the 27, you have 3 and 9. 9 is 3 and 3. So those two 3's pair up. The one that's left over stays under. It'll multiply with the I to give you 3I square root 3. Next, you have the -3I times the square root of 48. 48 is 4 and 12. 12 is 4 and 3. Not 4 and 2, 4 and 3. Your two 4's pair up. Your 3 stays under. So that's going to give you -3I times 4 square root 3. Then that square root 12. 12 is 4 and 3. 4 is 2 and 2. 2's pair up. 3 stays under. So that's just going to be 2 square root 3. From here, you are going to multiply with that 3I, that -3I, and that 4 square root 3. This is going to give you 3I square root 3 minus 12I square root 3 plus 2 square root 3. Now you have like terms. Your like terms here are the 3I square root 3 and the -12I square root 3. Yes, that 2 has the square root 3 attached to it, but work with these two first. If you combine these, you are going to have -9I square root 3 plus 2 square root 3. Now you can leave it like this, or you can simplify it even further. If you simplify it even further, your 2 is your real part, your 9I or your -9I would be your imaginary part. They both have the square root of 3 attached to them. So you'll go parentheses 2 minus 9i times the square root of 3. So you could give me what's in the pink, or you can give me what's in the green. It's up to you, but they both mean the same thing. If you were to put it in a plus bi form with what's in the green, it would turn into 2 square root 3 minus 9i square root 3. So that would be the standard form, or a plus bi form of that. For number 3, we have the square root of negative 50 plus 6 square root negative 45 minus 3 square root negative 75. I'm going to bring this down here in this black section and work it out down here, just that way we have a little bit more room when I take these negatives out. So first thing that we're going to do is take those negatives out. So we're going to take the negative out of the square root of 50. That's going to become I square root 50. Then we have the 6 times the square root of negative 45. So that negative would come out, represent it with I. So that's 6i square root 45. Then we have the negative 3 times the square root of negative 75. So that negative will come out, represent it with I. And then you have the positive square root of 75. From here, you are going to simplify those radicals. So that 50 is going to be 5 and 10. 10 is 5 and 2. So your two 5s are going to pair up. That 2 stays under. So those 5s are going to multiply with that I. It goes in front, and that 2 stays under. Then you have that 6i, plus 6i, and that's going to multiply by whatever that 45 under that square root simplifies to. So 45 is 5 and 9. 9 is 3 and 3. Your 2 3s pair up. Your 5 stays under. So that's 3 square root 5. Next you have that negative 3i times whatever that square root of 75 simplifies to. 75 is 5 and 15. The 15 is 5 and 3. 2 5s pair up. 1 comes out. 3's left over. It stays under. So from here, we are going to simplify this. Your 5i times the square root of 2 is going to stay 5i square root 2. Then your 6i times 3 square root 5. 6 times 3 gives you 18. Keep the I, keep the square root of 5. Then your negative 3i times 5 square root 3 is going to give you negative 15i square root 3. From here, you are going to simplify whatever you can. In this case, you do not have any like term because no number underneath that radical that's left over is the same. So because none of them are the same, you're going to leave it as that 5i square root 2 plus 18i square root 5 minus 15i square root 3. There is no a plus bi form with this since you do not have a term that does not involve an I. So in the order that it is right now is totally fine. For our next part, we are going to be dividing complex numbers. When we divide these complex numbers, you want to pretty much think rationalizing your denominator. Okay, so your whole idea is to get rid of the I in the denominator, which means, again, it's practically rationalizing your denominator. So take the so-called conjugate of your denominator, keep the two terms, but change the sign in between them, and then multiply the top and the bottom of the fraction by that. You will be left with a number in your denominator that does not have an I attached to it. So if we look at example A, we have 3 plus 5i over 1 minus 2i. So what I'm going to do first off is to put parentheses around both my numerator and my denominator. My denominator, I have the 1 minus 2i in it. So I'm going to keep the 1, I'm going to keep the 2i, but I'm going to change the sign between them to be addition. I'm going to multiply whatever I do on the bottom to the top as well. So that 1 plus 2i multiplies by the top and the bottom of this fraction. We're just going to FOIL this out. So 3 times 1 up top is going to be 3. 3 times 2i is 6i. 5i times 1 is 5i. 5i times 2i is 10i squared. In your denominator, you have 1 times 1, which is 1. 1 times 2i is 2i. Negative 2i times 1 is negative 2i. And negative 2i times positive 2i is a negative 4i squared. Combine your like terms from here on both the numerator and the denominator. You can also change that I squared to be negative 1. So up top, we're going to have 3 plus 6i plus 5i gives us 11i plus 10 times I squared. So that's 10 times negative 1, which is negative 10. On the bottom, you have 1 plus 2i minus 2i. Those are opposites, so they're going to cancel. Then you have that negative 4 times I squared, which is like negative 4 times negative 1. That'll give us a positive 4, so that's just going to be 1 plus 4 in the denominator. From here, you're going to combine your like terms. Keep your numerator in a plus bi form. So 3 minus 10 gives us negative 7 plus 11i over 1 plus 4 is 5. You have no common factors here, so that is the simplest form of this fraction. That is your answer. For example B, you have 7 plus 3i over 4i. If we put parentheses around our numerator, and if we look at our denominator, we just have that 4i in it. We said the other day that our real part, when we just have a term that has an I attached to it, is 0. So this is the same thing as saying something like 0 plus 4i. So the opposite of this would be the negative 4i. So if we had 0 minus 4i or just negative 4i, we would multiply the top and the bottom by that. We're on the top, we're just distributing in. So the 7 times negative 4i is going to give us negative 28i. Then the 3i times negative 4i is negative 12i squared. On the bottom, positive 4i minus 4i, or times negative 4i, sorry, is negative 16i squared. So now from here, since you don't have like terms that you can combine, just simplify that I squared. Again, we said I squared is negative 1. So both on the top and the bottom, they would turn into negative 1, giving us negative 28i plus 12 over positive 16. You want to turn that top into a plus bi form. So that would be 12 minus 28i over 16. From here, simplify if you can. You have 12, negative 28, and 16. They are all divisible by what? 4. So if we divide 12 by 4, that's 3. 28 divided by 4 is 7. 16 divided by 4 is 4. That gives us 3 minus 7i all over 4. If we look at some examples for this one, we have negative 5 over 4i. So again, we said that we're going to take the opposite if it's just one single term and multiply by the top and the bottom. I'm going to bring this negative up top with the 5. And then on the bottom, I'm just going to have that 4i. So to multiply the bottom by negative 4i, I'm going to do the same thing to the top. Your negative 5 times negative 4 gives you a positive 20. You keep the I. On the bottom, you have 4 times negative 4, which is negative 16, times I, which is I squared. The only thing you can simplify here with those i's is that I squared to become negative 1, which this would make it 20i over positive 16. From here, you simplify. 4 goes into both 20 and 16 evenly. So 16 divided by 4 is 4. 20 divided by 4 is 5. That gives you 5i over 4. For our next one, for 40, we have 9 over 5 plus 8i. So again, we're going to put parentheses around the denominator. I'm going to put them around the numerator too, just because that's the habit. We're going to keep the 5, change the sign to a negative, keep the 8i. Since we're multiplying the bottom by that, we're going to multiply the top by the same thing. So this is going to give us 9 times 5, which is 45. 9 times negative 8i is negative 72i. This is all going to be over 5 squared minus 8i squared. It's the same exact thing as foiling it out, canceling out your b term, and then just working with the first and the last term. So this is going to simplify to be 45 minus 72i all over 25 minus 64i squared. That I squared is going to turn that negative 64 into a positive 64. So you'll add the 25 and the 64 to give you 45 minus 27i all over 89. Think about these terms. Your 45 is divisible, or yeah, let's do, you can do 45, that's fine. 45 is divisible by 3, 9, and 5. Well, 3 goes into 9, so think 3 and 5. Do 3 and 5, either of those go into 89 evenly? No. So this does not simplify any further. That is your answer. The 27 came out of nowhere. Maybe the 72, I switched. So let's go back. Sometimes I have dyslexia. It's okay. So this would really be 45 minus 72i over 25 minus 64i squared. So then if we simplify this, it gives us 45 minus 72i over 25 plus 64. So then that would be 45 minus 72i over 89. So now you would look, the 45 is your smallest number. Your factors of 45 are 5, 9, or 3. Yes, 72 is divisible by 9, but 89 is not. 72 is divisible by 3, but 89 is not. Nothing else other than the 45 is divisible by 5. So again, this is simplest form. For our next example, we have negative 7 minus 6i over negative 2 plus i. I'm going to put parentheses around the numerator and the denominator. Multiply top and bottom by negative 2 minus i. And FOIL out the top. If we want, we can use the a squared minus b squared on the bottom, or we can FOIL it out. It doesn't matter. So negative 7 times negative 2 gives us a positive 14. Negative 7 times negative I is a positive 7i. Negative 6i times negative 2 is a positive 12i. And then negative 6i times negative I is a positive 6i squared. On the bottom, that negative 2 is going to get squared minus the I squared. So up top, we're going to combine like terms. That I squared turns into a negative. So from here, you are going to have up top 14 plus 19i minus 6. On the bottom, that negative 2 squared is 4. And that I squared is I squared. So this, no, it was plus 6, but because it was 6i squared, it became negative 6. Because the I squared is a negative 1, so positive 6 times negative 1 is a negative 6. So that I squared on the bottom is negative 1. Double negatives turn into positives. So this is going to give us 14 minus 6 is 8 plus 19i all over 4 plus 1 is 5. All right, so for our next one, for 42, we have 4 over 5 minus 10i. We're going to multiply the top and the bottom of this, once we put our parentheses around, by 5 plus 10i. So up top, we're going to distribute that 4 in. We'll have 20 plus 40 I. On the bottom, if we use that a squared minus b squared, we're going to do 5 squared minus 10i squared. So that's going to give us 20 plus 40i all over 25 minus 100i squared. That I squared is going to turn into a negative 1. If we multiply that negative 1 by that negative 100, it gives us a positive 100. So that's 20 plus 40i all over 25 plus 100. Simplifying that denominator, that gives us 20 plus 40i all over 125. What are all three of these numbers divisible by? At least 5. So the 5 goes into 20 4 times. The 40 goes into, or the 5 goes into 40 8 times. And then 5 goes into 12 twice with 2 left over. 5 goes into 25 5 times. So that gives us 4 plus 8i all over 25. For our last one, we have 10 minus I over 5 minus 10i. So for this, we're going to put parentheses around the numerator and the denominator. Multiply the top and the bottom by 5 plus 10i. So this is going to give us 10 times 5, which is 50. 10 times 10i is 100i. Negative I times 5 is negative 5i. Negative I times 10i is negative 10i squared. On the bottom, again, we're going to do the difference of squares, so that's 5 squared minus 10i squared. So this is going to simplify to give us 50 plus 95i minus 10 times negative 1 all over 25 minus 100i squared. We're going to simplify even further. So that gives us 50 plus 95i plus 10 all over 25 minus 100 times negative 1. Again, keep simplifying. The 50 plus 10 gives us 60 plus 95i. On the bottom, you have 25 plus 100. So then we add on the bottom, and we get 60 plus 95i all over 125. Once again, all three of these numbers are divisible by 5, so we're going to divide all three by 5. We said that on the first one, or the one that we did before this, that the 5 goes into 125 25 times. 5 goes into 60 12 times. 5 goes into 95. 5 goes into 9 once with 4 left over. Then that makes 45, so 19 times. So that's going to give us 12 plus 19i all over 25.